Quasar E-Motorsports.
What's up, guys? This is Quasar, and welcome to another beautiful day. Today we are at the computer. We are going to get the side panel for the battery box in. This is what I've come up with so far. I've taken my little drawing here, and then back here I've got some dimensions. And I've entered it into Fusion 360. I made a sketch. I got all the holes where they need to be. Put a nice little Q for Quasar right in the middle of there. And then I went ahead and extruded it. This is taking forever, by the way. I'm pretty new at Fusion. I think I'm doing all right. So let's have a look at the body. And we'll take away the sketch. And I think that's a pretty sweet side cover. The CNC should do a real good job of that. I did fix this bottom corner over here. Let me see. There's the mouse. I fixed this bottom corner over here. We only had one bolt in there because I had I'd messed that up prototyping, but I really feel like that's pretty cool. That's a nice little sweet side cover. The Q is inset in there. This is a 4.76 millimeter thick piece of aluminum, or 3/16. I sunk that Q down to 2 millimeters. Put a chamfer around it, make it look real good, but I think that's a good start. I might just click save on this one. I think it's pretty sweet, but yeah. All right, so we're gonna get on to the next panel, which is gonna be a little more tough than this, but I think that it's gonna come out just as nice. All right, so we've got the quick release side of the tray done. This is what it looks like. It's got the Q inset in there. I like the design. I think it'll be nice. And I kept the similar geometry as the left-hand side, which is the sprocket side of the bike. You can see I had to make that Q custom. I got it to look just like the other Q. Wasn't easy, but yeah, I'm new to Fusion fairly, so I'm doing the best I can. But I think that I'm doing pretty good. I'm happy with the way it looks. So, yep. So that is left and right side of the battery tray. That is a huge difference between what it looks like over here. Honestly, like, it looks cool, but that's honestly ugly as shit. So once we get that cut out on the CNC, it's gonna be beautiful. Still not sure what I'm gonna do with the motor mounts. I don't know if I'm gonna skeletonize them or not, but we'll see what it looks like once we get this on. And then we gotta CNC these blocks. Gotta design something up for those. I'm thinking about doing kind of like a wedge and then maybe a trapezoid, tapering it off. And then we gotta skeletonize that. We'll do the CAD file for that either later today or tomorrow. But yeah, it's coming along. The CAD work is a ton, and I haven't even gotten into the tool paths yet, which is going to be pretty insane. I'm a beginner with that, so we'll see how it all comes out. But so far, so good. I know we've jumped ahead a bit, but let's see what we had to do to get to where we are now. Alright, so I'm digging the way that the front tray mounts are going down. And the way we're going to do the rear is we're going to have to make a piece that goes like this right here. And we're going to bolt it through the top. So it needs to be at least 3/8 inch thick. That way we can tap it up here and then bolt that down from the top. And then we'll use a little bolt here. Not only will that hold the tray down, it'll give it an extra piece of support. So we have 1, 2, 3 mounting points on this motor, and we'll have a fourth over here because this will be attached to the front frame over here, and this will be attached to this plate, which is attached to this. So we'll have a fourth mounting point for the motor, making it even stronger. It doesn't really need it. I usually cut these off, but in this case, because I want it to be bolt-on, I have to leave the motor as it is to get everything to be bolt-on and easy. And unless I wanted to cut these off of every motor I send with this kit, which just doesn't make sense when I can make it fit without doing all that. Alright, so we have to drill an 8mm hole into this. We're going to do a 25mm length. I'll drill the hole first because it's going to be a lot easier to drill it before we cut it than after we cut it. We're going to cut this a teensy bit long so we can dial in the length that we need exactly. So So I marked it at 25. I'm gonna give it an extra 1/2 millimeter. I think that'll be good enough. All right, we got these all dialed in, centered and center punched for 5mm holes. We're gonna go ahead and drill it. Let's go ahead and countersink them. Okay, we're going to move on to drilling and tapping. Got an M5.08 tap with the appropriate drill bit. We're going to put these in the drill press vise, get those drilled through, and we're going to tap them by hand, and then we're going to test fit. We're going to go ahead and give these a good center punch, and then we're going to drill them nice and slow. We don't want to go too fast because we do not want to round out the holes. If you go too fast, you'll get aluminum bits in there and it will round out the holes. So when you're doing precision or small bits, small taps, you want to go nice and slow. Alright, anytime you tap anything, you want to use a bit of tapping fluid. I keep it in an oil can, but you throw a bit in there to reduce the friction. And I just put a few drops in each hole, and then every time I tap, just put a little bit on my tap. Alright, the trick is you want this as straight up and down as possible. You do not want to tap a crooked hole. And it will kind of guide itself to a point. But if you start the hole crooked, you could definitely get a crooked hole in there. Get a crooked tap. You don't want that. And once you get down just a little bit, probably don't need this. It's a good idea to back it out if you get any resistance. So you can pull some of those chips out of the hole. So you got a bit of resistance there. Back it out. That'll clear the chips. Keep going. This will bottom out about 1/8 of an inch or so, depending on the tap, shorter than what you want your taps. So whatever depth you want your threads to be, make sure that you drill your hole 1/16 to 1/8, depending on the tap, deeper. So back and forth a little bit. When you feel that resistance, don't keep going because you will pull the threads out of your tap. Okay, we're at the bottom. Back it out. Nice and gently. Clean off your tap. Proceed to the next hole. Anytime I'm tapping holes, if I can, I use the drill press because you get a vertical hole. If you try to do it with the drill, it's highly likely that you will get a hole that's, crooked, and then when you go to tighten the bolt down, the crooked bolt head doesn't want to grab the work very nicely. Whatever it's tightening down, it's going to be an issue. So definitely want to get your hole straight as possible. All right, we're at the bottom. This is fairly easy. I'm not sure if I'm going to write a program to tap all these in the CNC. I know it'd be easier, but I'm not super in-depth at that, so I'll probably just tap them by hand for the kits. It's not that big of a deal. It doesn't take much time, as you can see. You could even do this with a drill, but I don't recommend it for shallow holes like this. Aluminum and a drill works good. Just make sure you're lubed up really nice and go slow. You don't want to go fast. And if you're doing through holes, if you're doing holes that stop, I would not recommend using a drill. Definitely do it by hand. You won't be able to stop where you need to, and yeah, you just eat all those threads you just put in there right out. So this goes fairly quick anyway. Aluminum's pretty soft, and this is a hardened steel tap. I believe this is high-speed steel, which is what I'd assume. High-speed steel is a little less brittle than, say, something like tungsten. They do make tungsten taps. Those are for harder metals, typically hardened steel. High-speed steel can do most hardened steels. It just depends on what type of steel it is. All right, I think we're there. Yeah, we're there. All right, after this, we're gonna clean it up, blow it out with the air, and we're gonna test fit. I'm not too worried about this. You'll notice over here, I sanded the wrong corner down. This is prototype stuff, so no biggie. But pull these out of the vise, clean them off with some air, and test fit. Well, look at that. Sure does fit nice. Got a nice thick tab there. A lot of meat. Should hold down real good. That'll act as fourth motor mount and to keep this battery tray stable. We've got those angle brackets there. That works really nicely. Gives some heft. And we're gonna make the battery holder, that quick swap battery holder now. So that's gonna be fun. All right, so we've got the first side panel cut out. We're gonna have to cut this. This is a 1/2 inch by 1/2 inch. We're gonna do 20 millimeter sections here. We're gonna do 3, one in here, one in the middle, and one over here on this side. And this is gonna bolt to the bottom of the battery tray, and then this will overlap and bolt onto that. So that way we have a way to rigidly mount this side panel. And then we're gonna take a cross section that comes off the top of here that goes to the other side of the battery, and that's where we're gonna have a hinge and a drop down that's gonna have a latch on it, or 2 latches, and we'll be able to latch the battery case down. On the ends here, we're gonna put 3/8 thick aluminum. The tabs are gonna come out about this far. They're gonna be bolted on here and here, and that's gonna hold the battery from going back and forth. Both side panels will have those to retain the battery in there and make it light as possible and, you know, as simple as possible. So I went ahead and marked all these out, the screw locations, and countersunk and drilled them. This is an M5 stainless steel screw with a 10 millimeter cap head. This is just the side mounting point. It's going to go into these blocks. We're going to tap these like so. And then this is going to attach to this plate under here. And then the bottom of the battery tray will tap into the top of this the same way we're doing it here, just in between these screws. So we've got every hole here marked out, drilled, and countersunk. I already transferred all the data to my data sheet. That way I can reproduce this in Fusion 360 for the actual finished CNC version. I did mention, I think, that this is all just prototype, so it's just going together how it is right now. This is going to have spacing in here and open parts, probably trellis-like, or maybe even exterior-like. It's going to look really cool. It's not going to just be a flat plate, but we've got that marked out. Now we're going to go ahead and tap and drill all these pieces that are going to go on here. I'm gonna go ahead and tap this the way I should have originally done in the first place. When you do it in a drill press, and you can just, if it's not too big of a tap, you can just turn this without powering it on, and that'll actually give you a very nice vertical tap. So that's what we're gonna do. Okay, so this is what we've got so far. This is just a rough draft. There will be pocketing and cool design up in there to show off the stainless steel battery box, and I might put maybe my logo, maybe some lightning bolts or something cool. I'll add that later though. I mean, even like these sides, I made them really thick so we get good grab at the bolts, but you know, those will be chamfered and they'll look nice. The corner here will be taken off. This corner will be rounded probably. This is just a rough draft, but that's the idea. Get a rough draft, get all the input measurements for the CNC, and then cut out a final draft that's going to be amazing. So that's the goal here. We've gotten a lot done on this so far. I think we're going to move on to the other side with the latching system. And yeah. So we've got our shape for the other side. Went ahead and marked it in, center punched it. We're gonna go ahead and drill that and countersink it, get the battery hold downs on there, and then we will move to the hinges. Use 2 of these stainless steel hinges right here. It's gonna flip up from the bottom and then latch up at the top. So I totally made a mistake. Luckily, you make a prototype first. I had put this hinge here. I had measured it out to be equidistant with this hinge, and I forgot that the little right angle or 90-degree support was right here. So I didn't clear it, so I had to do that again. And I've got extra holes in my cover, which is cool because, again, this is a prototype. I did get the latch on, and yeah, it's pretty awesome. And that's never going to come up. It locks down. So we're going to go ahead and test fit this, and we'll be right back. All right, folks. So here's the moment most of us have been waiting for. I know I have. Here's the battery. We're going to see how long it takes to put a battery in. Done. Fits nicely. That battery does not move. I'm going to put some padding around. And mind you, this is going to be negative space or skeletonized and it's going to look badass. The other side is going to look awesome too. But one of the major ideas here was to protect the battery in the event of a crash and to make this thing last. You know, I want to be able to swap a battery quick, and I also want to be able to protect the battery if you wreck. I mean, I can imagine people hitting some pretty big jumps on a bike like this, and that battery is going to be safe. You know, these are going to be skeletonized and CNC'd, so it's not going to look like a block. It's really just a base, chunky material. We're going to trim all this down and smooth the edges and skeletonize everything. It's going to be pretty sweet, but I really like the way that works. The stainless steel hinges that are polished, those are marine grade. You know, we've got a 3/8 inch thick aluminum plate up there. We'll skeletonize and make that awesome. All this will be CNC'd and skeletonized. All the stainless steel hardware is countersunk. Down here we've got a nice thick 90-degree aluminum mounting bracket there. I've got new hardware for everything, so this is all 3/16. The bottom plate is 1/4 inch thick, and everything inside there is countersunk as well. I mean, if you can use your imagination a little bit and try to look at that skeletonized, it's gonna be pretty sweet. So yeah, I'm not sure what I'm gonna do next here, but it's gonna be probably some finishing up to do. As you can see, I need to pad some of this in here. The box has a lip, and there's a screw which offsets the box entirely, which is not a problem because I can use some HydroTurf in here. I'll probably do it on both sides, and that'll make the clamping force even nicer. I don't think I'm really gonna have to do anything else. I was gonna make the top and the sides adjustable on one side so you can push them in and out, but I think the foam will do just fine. It's clamped down in this box. This thing is it's not moving. Let's see. That latch is a thick stainless steel. I don't worry about that holding up much at all. That's gonna be great. You know, and it pops right out. And then the battery's out just like that. Yeah, pretty sweet. I could probably do this with one hand. Let's see, this is the first time I did it. I waited for you guys. Easy peasy. I like the design. I think it's gonna work great. Again, it's gonna be skeletonized, which is gonna be really cool. I'm not sure if I'm gonna skeletonize the lower mounts because I'd like to keep dirt and debris out from under there. But give me your opinion in the comments. Let me know what you think. Maybe I will, maybe I won't. Up here is not so bad because obviously nothing can get in there, so that'll be just fine. If I skeletonize it, I will also have to CNC out some of that HydroTurf that I like to use for the padding. As a sticker, basically, you can stick on the inside. But so far, everything bolts together. It's fairly simple. I mean, it'll probably take you an hour. Once you have your motor out, probably take you an hour to build the kit, wire it all up, depending on your skill level, of course. But I really like the way it came out so far, and stay tuned for the next video. We're gonna be getting into some CNC work and wrapping some other things up. But yeah, stay tuned. Please like and subscribe and follow me for more.